Hello, everybody. My name is Charlie, and I am one of the lovely learning assistants here at the Math Zone. And today I'm here to talk to you guys about triangular trigonometry and inverse trigonometry. So I'm sure you guys have seen Kenny's videos on trigonometry. So you learned all about the sine, the cosine, the tangent, all sorts of good stuff like that. And I'm here to really build upon your foundation and give you more examples on how this may apply in your classes. So first, we're going to talk about some learning objectives. So first, what is Soh Cah Toa? I'm sure you guys have heard that about 1,000 times before, but I'm really here to hammer it home because if enough people will describe it to you in different ways, one of those ways is actually going to help you learn. It's going to stick in your brain. Number two is how to use inverse functions to solve for angles and the sides of a triangle. And then number three is how to use inverse trig on equations with multiple functions. You guys are ready? We're going to go ahead and get started. We're going to start with one of our basic definitions. So Soh Cah Toa is an acronym used to help mathematicians solve trigonometric problems. So if you look at Soh Cah Toa, we have Soh. So we have sine equals the opposite over the hypotenuse. Cah, which is the cosine, equals the adjacent over the hypotenuse. And tan, where the tangent of the angle equals the opposite over the adjacent. So think about it this way. You have an angle that's 10 degrees, and you know your hypotenuse is, say, 14. You can use the so aspect to find the opposite. This means that sine 10 is going to equal something over 14. When you get there, you just cross multiply, and then you're kind of good. We're obviously not going to solve that out, as I was just giving you an example on how this may be used, but it's very useful to keep in mind on all of our later stuff. So you may be thinking, not necessarily you as middle schoolers, but you may have been thinking about this when you first learned about trigonometry in middle school. Yeah, I know what sine is, I know what cosine is, I know the unit circle. This is so easy. And of course, here comes the arc functions. So arcsine is the inverse of the sine function. Gives the angle for the given sine value, which is written as sine to the -1. If you look at your calculator, you may see you have that button. If you never knew what that was for, well, now you know. It's going to be used for the arcsine. The arc cosine is the inverse of the cosine function, which gives the angle for the given cosine value, and that's written as cosine to the -1. Finally, we also have the arctangent, which is the inverse of the tangent function, gives the angle for the given tangent value, written as tan to the -1. So keep that in mind because these specific writings especially will come up later in this presentation. Now we have to keep this in mind too. You cannot treat the inverse functions like exponential values that will give you the wrong answer. If you know how exponential values work, you'll know that x to the -1 means you get 1 over x. That is correct. So like x squared would give you x squared, but x to the -2 would give you 1 over x squared, all that good stuff. But sine to the -1 of x is not 1 over sine x. Sine to the -1 means you're doing the inverse of that. So if you think about like your regular equations, so let's say x plus 2 equals 4. To find out what x is, you do the reverse of that. So you subtract 2, you get x equals 2. That's kind of very similar to what we're doing here. So you're just taking the reverse of that. So here's how you solve triangular trigonometry with inverse functions. Your step one is you're going to want to determine what piece of the triangle is missing. So whether it's the angle or the side, and then what information you have. So if a side is missing, but you have the angle and everything like that, you can just use Soh Cah Toa. You just got to figure out which side is missing. However, if an angle is missing, you actually have to go in depth and start using the inverse trigonometry. The rest of these steps are going to go into more detail on how to use that. So first, which sides are given is going to tell you which inverse function to use. So of course, like again, that's where Soh Cah Toa comes into play. So say you have the adjacent and the hypotenuse, you would have to take the arc cosine of the angle and or of that number that's given to you, and that will give you the angle. So step 4, you're going to find the opposite over the hypotenuse, the adjacent over the hypotenuse, or the opposite over the adjacent, depending on what sides you have. And then, of course, step 5, here's how we do it. If you're using the opposite over the hypotenuse, you take the arcsine. If you're using the adjacent over the hypotenuse, you take the arc cosine. Finally, if using opposite over adjacent, you'll take the arctangent, and that gives you the angle you need to use. So if that makes sense, Or if you're a little confused, I'm going to show you some examples that may help put that into perspective for you guys. So this is one of the ones that I talked about earlier, where you're actually going to go ahead and solve for this. So one of the things you'll need to know is that you have that sign to the -1. So that is, in fact, a thing fully on your calculator, which is awesome. So what you're going to do is you're going to take your calculator. Firstly, right now, what I have right next to me is my phone, which is awesome. So if you pardon me, I'm going to pull up a calculator that I can use. But first, what we're going to do is then we're going to plug that in. So you're going to get a number for that. And mine, personally, is going to be sine to the -1. So keep in mind, you can also just plug it in that way. So you're going to be able to get your sine to the -1. Perfect. -1 of, and then you can't forget to put that in parentheses. So it does have to be 8/13. If that's not in parentheses, it's going to try and take the sine to the -1 over just the 8 and then divide that whole thing, which is not what you want at all. So you have to make sure you get that. So when you have that, we're going to evaluate that. And you're going to get something around 0.66. What a fun number. So then you're going to take the tangent of that. So the tangent of that is going to be 0.66. Is going to be 0.77. Now that doesn't make sense, right? You can't have an angle that's like 0.77 degrees. So you have to make sure that your calculator is set to radians, not to radians, to degrees. So you have to make sure you convert from that because that's going to give you your degrees. So what this actually is it's going to be the tangent function of it's going to be tangent or tangent function of actually 37.98 degrees. Now that makes more sense, right? So then we're going to take our tangent of 37.98. And then, of course, you have to make sure to put your degree symbol in there because otherwise it'll take it to mean something totally different. Now, where you find your degree symbol, you should know where it is on your calculator. So I'm going to just go ahead and do that too. And now that is going to give me the tangent of 37.98 in degrees. It's going to equal in degrees, apparently. It's still giving me 0.7. That's interesting. Which upon further analysis does actually give you something very close. It's actually 0.78. At least that has been peer reviewed and checked. So keep that in mind. It may be similar, but it's still different. So now we are going to clear that. And we're going to go on a problem that actually would look very similar. But this one actually has some drawings involved. So this is example 2. For the right triangle below, find the measure of the angle. So you know that you have some sides. So if you look at a triangle, this, you know, is your hypotenuse right here. So your angle is right here. So this is your adjacent, your opposite, and your hypotenuse. So looking at it, you have your adjacent and you have your opposite. So using Soh Cah Toa, Soh Cah Toa, you know, just by looking at it, you're going to have to use Toa. So, so now you don't have the angle. So you know that your tangent of the angle is going to equal, also equal, your opposite over your adjacent. So that means it's going to equal 6 over 11 is the tangent of your angle. Now you don't have that angle. So you know that you're going to have to take the tangent of the -1. So the tangent of the -1 of 6 over 11, and make sure again that your calculator's in degrees, you do not want it in radians, is going to be tangent to the -1 of 6 divided by 11 in degrees is 28.6 degrees. So there you have it. You know, kind of relatively how to do the inverse of certain things. This is certainly very useful because you do have a calculator function that'll do a lot of that for you. But it's worth keeping in mind to know exactly how to do it. Again, here's another angle. So you know that you have an angle missing. So you want to find this angle. This is the hypotenuse. This is the adjacent. This is the opposite. Look again at Soh Cah Toa. You have the A and the H, which means you're going to use the cosine. So the cosine of your angle is going to equal 12 over 13. So then the arc cosine, or again, cosine -1 of 12 over 13 is going to give you an angle of, let's not clear this, cosine of -1, 12 divided by 13. An angle of 22.6 degrees. So there you have it. Those are just two more examples on how you can use the Soh Cah Toa method to solve and help you with inverse trig functions. So now you kind of have a baseline setup on how to do all these problems. This will be especially useful when you go to do your homework. So obviously, you're wondering, when I go do math, what does this have to do with me? This doesn't matter, right? That's what you think. Well, not in triangle form. Inverse functions will appear in Calculus 1, Calculus 2, and Calculus 3, which, you know, some of you may not be taking, but it's worth keeping in mind that the foundations you're building right now are going to be useful later on. You also use them to solve for x in multiple equations, and they can be useful in taking derivatives of certain functions. Now, if you don't know what a derivative is yet, don't you worry, you will learn. In real life, however, many architects do use triangular trigonometry to determine what bridge angle is best with the length they have planned. So if you look at this, if you look at the bridge very specifically, you can see that there is it almost looks like a triangle, right? Here's your triangle. No, not necessarily a right triangle. You do want to know what specific building arch that may want to be, and you're going to look at it from like this. So therefore, you know what way to build it, because you can split anything into basically a right triangle like that. So hopefully that makes sense. Now here's some sources. So obviously I have your Soh Cah Toa method. You use some things from my open math as examples. And of course, I stole my memes from Reddit, which are of course I've cited right here. So thank you guys for coming along with me on this lovely journey. I hope I was able to help you guys make some sense or semblance of how to do inverse functions. And of course, if you have any further questions, any of your teachers are here to help you guys. And we're always here in the Math Zone for walk-in appointments, or you can make an appointment through Navigate. Thank you all for listening to me, and I hope you all have a great day.